Let's tie up some loose ends with polynomials. Just like it says. Okay, end behavior shortcuts and standard form versus factored form. We're going to start with the end behavior shortcuts, and here we go. So let's use a blue pen. State the degree, leading coefficient, and end behavior for each of these. Now, I'm just going to make a little chart. We're going to say we have a degree. Let's try to make that look a little neater. Degree, that looks neater. Leading coefficient and end behavior. And instead of doing the end behavior like as x approaches infinity, y approaches negative infinity, like instead of that, we're going to just use arrows. Just use that. So there's that. These four, we're going to do them very quickly. And then we'll discuss what we have. Okay. Switching to purple. The degree of this very first one, one more in blue there. The degree of this very first one, highest exponent you see is a 3. The leading coefficient is not 1, it is negative 1/2. The end behavior is, well, let's find out. I've graphed it on Desmos, and I'm going to pull this up. Well, slide this under. And there's the graph. And the end behavior is as x approaches negative infinity, y approaches infinity. As x approaches positive infinity, y approaches negative infinity. Let's rephrase that. Looking at the left side, it's going up. Looking at the right side, it's going down. We're going to call it, well, up, down. Don't make it harder than it is. Up, down. Okay, next. The degree of this one is 6. The leading coefficient is 1/4. It is truly in the front. If I were to graph that one, which I already have on Desmos, you're welcome, then we would have this. Okay, kind of hard to see. I'm going to do this thing I can do on a touch screen and do that. Oh, there it is. There it is. Up, up. Looks like up, up to me. Up, up. Now, sometimes when I draw these arrows, they look vertical. Sometimes they look kind of slanted. And just real quick, let me show you why I do what I do. If you want to make them like up, up, you can. But you could also say, well, you know what? As I go to the left, I'm going up. As I go to the right, I'm going up. So sometimes I'll slant them. Not a huge deal either way. But if you see me slanting something, like this one's kind of slanting a little bit, that's why. Okay, degree of this one is 3. Leading coefficient is not negative 1. It is positive 2. So let's do that one as well. Look what we have. X approaches negative infinity, y approaches negative infinity, x approaches positive infinity, y approaches positive infinity. Let's just talk ups and downs. Down, up. Okay? Down, up. Here we go. Degree is 2. Leading coefficient is negative. Let's do that one. And this is what I have. That looks like down, down to me. Okay. Down, down. You ready for the shortcuts? All right. If your degree is even and your leading coefficient is positive, up, up. If, this only works for polynomials, by the way. If your degree is even and your leading coefficient is negative, down, down. Okay? Helps to memorize the chart. Actually, don't memorize the chart. Just know it. Like, if I have an even degree, like y equals x squared, here goes, scrap paper. Y equals x squared. If I do y equals x squared, I know the graph looks like this. That's up, up. That's an even degree, positive leading coefficient. You can just go back to the most basic ones when you're trying to remember these. All right, degree is odd. Leading coefficient is positive. We're in this situation. That would be down, up. Again, if you forget it, you know this. That's odd with a positive leading coefficient, and it would be like that, down, up. And then the opposite would be true for this one.